Okay, so now on to our P2 practice of kinematics. And the first question says that a car of mass 850 kg tows a trailer in a straight line along a horizontal road as shown in figure 2.1. The car and the trailer are connected by a horizontal tow bar. The variation with time t and velocity v of the car is shown, right? Calculate the distance traveled from t equals 0 to t equal 10. Now, the distance is the area under the velocity time graph. So let's just find this area. So this is the area we need to find. So this is a trapezium. So apply the trapezium formula. The sum of 13 and 9. 13 and 9 multiplied by its height, which is 10. So this gives us 110 meters. So this is the answer. At time t is equal to 10, the resistive force acting on the car due to air resistance and friction is 510 newtons. And the tension in the tow bar is 440 newtons. So now this is not concerning, should not concern you right now because I've only screenshotted the kinematics part of the question. So for the car at t is equal to 10 seconds, calculate the acceleration. Now, the acceleration of this would be, because this is just a constant, right? This is just a constant line. We can take the acceleration here from any 2 points, right? Let's just take this as our 2 points. So this becomes m is equal to 13y minus the other y, which is 9, and the time, which is 10, minus 0. So acceleration comes down to 0.4 seconds, 0.4 meter per second square, right? So this is our answer. Moving on to the second question. Now, a ball of mass 0.4 kg is projected into the air from horizontal ground as illustrated in 2.1. Now, the ball is launched with now this is not concerning you. This is only concerning for the next parts. The only thing you need to know here is for the movement of the ball from x to y, draw a solid line in figure 2.1 to show the distance moved, right? So the distance moved would be a parabola path right here. So this is our path D, right? And for the S path, which is the displacement, this would be from the center of the ball to the center of the ball here. And this would be S, our displacement, right? Now, going one step further, define velocity. So velocity is rate of change of displacement, or otherwise said that change of displacement per unit time, which is also fine. Now acceleration, rate of change of velocity. All right. Now, the graph shows us a displacement time graph, right, of a car of mass 1500 kg traveling along a straight horizontal road. So use figure 3.1 to describe qualitatively the velocity of the car during the first 6 seconds of the motion shown, right? So just have to describe the motion of the graph, motion of the car through the graph. Now, the thing that you need to understand about describing graphs is, first you need to see the graph, right? A property of a graph, and then relate it to real life, right? So the first thing is, let's just take it till here, right? So this is a constant velocity, constant gradient, right? So the first thing I'm going to write is gradient constant from t equal 0 to t equals 2.0, which means, which suggests, or which means constant speed at that time, right? Now, the second thing is the gradient after this, you will notice is something like this still here, right? This is a curved gradient and this is decreasing curve, right? This is a decreasing curve. This is an increasing. I'm sorry, it's not this. This is an increasing curve and this is a decreasing curve, right? So this one resembles a decreasing curve. So this means that velocity is decreasing. So between t equal to 0.0 and t equal 4.0, the gradient decreases, right? Which suggests that speed decreasing, right? Velocity. You have to use the word velocity here. This is my bad, right? And the next afterwards, gradient is constant afterwards, which means constant velocity, right? Velocity. Now, the question asked you to give the answer in qualitative form, so you don't have to include any numbers about the accelerator velocity. Calculate the average velocity in this. So, as we did in the previous question, just select, this is basically the 2 points. This is a constant line, so select any 2 points that you find comfortable. So I'm just going to select here because this is a nice round number, right? The first point, and the second point for me would be 0, 0. Yeah, 0, 0. Now, y2 minus y1, so y2 is 30 minus 0 divided by 1 minus 0. So average velocity is 30, right? Yeah. So for this part, show that the average acceleration between t is equal to 1.5 and t is equal to 4 is negative 0.72 meter per second, right? Meter per second squared. So what we do here now is just find the velocity at t is equal to 1.5, velocity here and velocity here, right? And apply the acceleration formula. So we know that the average velocity at t is equal to 1.5 is 30, right? Let's just take this as initial. And at 4, now at 4, you will notice that this line just becomes a constant, right? So just take any 2 points on this line. Let's just take this one and this one. The coordinates of this line is 1, 1, 0, 5, 1, 1, 0. And the coordinates of this line is 4, 1, 98, right? So the velocity here would be, let's just find the velocity here first, v2, which is 5 minus 4 divided by 110 minus 98. So this becomes no, this is the wrong formula. This is my bad. Just write 110 minus 98 divided by 5 minus 4. This becomes 12, right? So the initial velocity was v1 was 30, v2 is 12, and the time it takes is t is equal to 4 minus 1.5, right? So this becomes 2.5. So this is everything we need for this formula. So let's just apply the formula. A is equal to final minus initial divided by 2.5. And this comes down to negative 7.2. So this is our acceleration for this journey. Now on to the next one. A cyclist travels along a horizontal road. The variation of t and v is shown. The cyclist maintains a constant power and after some time reaches a constant speed of this. Describe and explain the motion of the cyclist. Now just ignore this power part and just focus on this 12-meter part, which is the constant speed that it reaches, right? That he reaches. Now, for this one, to answer this one, you need an understanding of drag forces, which is, to explain this, you can't explain this right now. So let's just move on. You'll learn how to explain this phenomena in the next chapter. So use figure 3.1 to show that the acceleration of cyclist when his speed is 8 is about 0.5 seconds, right? Meters per second. So what we do here is just draw a tangent here and draw a line and find its gradient. Now my line is by no means straight, but let's just see if we get a close enough answer. So the first point is 4 and 7. And the second point that I'm going to take here is basically this one. Let's just take this one, which is 10.2 on the y-axis, right? And this here is, let's just take it to be this point, right? Let's just take it to be this point. 11. $10.4, 10.8, and 11.2. So this is, I don't know why I wrote a 4 here. This is, this is 4.7. And this is 11.2 and 10.2, right? So let's just see if I get a close enough answer. If my answer is close enough, I'm fine with that because this is not a straight line. -4. Yeah, so I got the answer 0.45, which is close enough. If you draw a straight tangent, you'll get a better answer. So let's just move on. Now, the drag force D of an object of cross-sectional area A moving speed V through a density of P is given by this, right? Where C is a constant, show that C has no units. Now, let's just do this. Now, force is, this is a force, right? So D, the units of D would be MA or kg meter per second square, right? So this would be the unit of T. The C is a constant, P is mass or meter cube, right? Area is meter square and V is meter per second. So we can write it as second square is equal to C. Now 1/2 has no units, so let's just ignore this. Times rho. Rho has units, kg meter -3, right? Times meter square times meter per second square, right? Because velocity is squared in the equation. So the first thing we can do is just cut out the kgs and write meter per second square is equal to, now for this one, this just becomes meter -1, right? meter negative 1 times meter square second negative square. So meter second square. Now this becomes meter second negative square. So these two cancels out and C has no units, right? No units. So this stuff. A raindrop falls vertically from rest. Assume that air resistance is negligible. On figure 1.1, sketch the graph to show the variation with time t of the velocity v of the raindrop. Now, the gradient of this, we know that the gradient of this graph would be, for the first thing we know is it starts with 0, 0, and the gradient would be, what would be the gradient? G, right? Because the gradient of this velocity time graph would be the acceleration, and acceleration in this case is 9.81. So the graph would be something like this. Yeah, it would be like this actually, right? Because they only asked us to draw the first second, so just draw this. Calculate the velocity of the raindrop after 1000 meters. So again, write everything that you have, 1000 meters, right? And this would be negative because it's going downwards. Acceleration, negative 9.81, right? U is equal to 0, right? Even from here, vertically from rest. So U is 0, and V is something that we need to find. So V square is equal to U square plus 2AS. So V is equal to, U is 0. So 2 times negative 9.81 times negative 1000. So these negatives cancel out nicely. So you have done everything correctly. So this becomes this becomes 140, about 140, right? So rounds off to 140. Now, the next question is, the ball is thrown against a vertical wall. The path of the ball is shown. The ball is thrown from S with an initial velocity of 15 at 60 degree to the horizontal, right? So for the ball at S, calculate the horizontal component. So horizontal component would be this. So 15 cos 60, which would come down to 7.5. And the vertical component is 15 sine 60. So this would be 7. This would be 13. Sorry, it's 13. Yeah. Now, the horizontal distance from S to the wall is 9.95. The ball hits the wall at P with a velocity that is at right angles to the wall, right? So the vertical, what this tells us is this was right angle. So there was no horizontal component here. So this was perfectly aligned where the horizontal velocity was 0, right? So all of the horizontal velocity that it had from this component was gone because of the acceleration downwards due to gravity. So this is what this right angles to the wall tells us, right? Because if it hits at an angle, it's not at the path where it doesn't have any vertical velocity. And if it hits at a very acute angle, right? This angle, you know that it's ahead of the point where it has 0 velocity. So it hits perfectly where the velocity was 0, right? So vertical velocity vertical is equal to 0. Yeah. The ball rebounds to a point F, right? It rebounds to here. Using your answer in A, calculate the vertical height gained by the ball when it travels from S to P. Now, you know that the vertical component is fully used up, right, by the acceleration, and it is 0 now. So what we have here is basically A is equal to vertical height, right? So S is equal to unknown, right? Because we're just taking the vertical component right now. So the initial velocity was vertical component 13, final velocity was 0, right? And the acceleration was negative 9.81. So Just apply the formula v squared is equal to u squared plus 2as. So this becomes 0 is equal to 13 square plus 2 times 9.81 multiplied by s. So if you solve for s, this gives you 8.6. 8.6 meter is the answer for this. Okay, so show that the time taken for the ball to travel from S to P is 1.33. So the distance that it travels is 9.81, right? The distance it travels is 9.81, 9.95, and the component of horizontal velocity is 7.5. So just take it like this. So speed is equal to, velocity is equal to displacement over time, which becomes time is equal to displacement divided by velocity. So the displacement is 9.95 and the velocity is 7.5. So this gives us 1.33 approximately. Moving on. So this question here, the ball is thrown horizontally from the top of a building at 8.2 meter per second. The ball is thrown with a horizontal speed. The side of the building is vertical. At point P, the path of the ball is distant x away from the building at P. Air resistance is negligible. For the ball at point P, show that the vertical component of its velocity is this, right? So at point P, air resistance is negligible, right? So this is the triangle at P. This is point P. This is the velocity 8.2 because it hasn't decreased because air resistance is negligible. And this would be the vertical component, and this is angle 60. So this is the simple tan 60 is equal to perpendicular over base, which is 8.2. So this P becomes 14.2. So this is the vertical component here, 14.2 meter per second. Determine the vertical distance through which the ball has fallen. Now, the vertical distance is, to determine this, another quadratic equation is required. The vertical velocity u initially was 0. The vertical velocity was finally 14.2, right, at P. All right. The distance is, we don't know. And another thing that we know is acceleration, which is negative 9.81. So let's just apply v square is equal to u square plus 2as. And remember to write the formula in the exams because there is a mark for a formula. So 14.2 square is equal to 2 times negative 9.81 multiplied by s. So s becomes, so the s value becomes 10.3 meters. Negative 10.3 meters because the displacement was downwards and we took downwards to be negative. So it was negative 10.3 meters, right? Now, determine the horizontal distance x. The first thing you're going to need to do is calculate the time taken for the ball to reach here, right? Yeah. So the second part, determine the horizontal distance x. So this is 8.2 is the speed, distance is x, and the time, we don't know the time, right? So to find the time here, we just use the vertical component to help us, right? We just use the acceleration formula. Acceleration is equal to v2 minus v1 divided by time. So time is v2, which is 14, right? 14.2, final velocity here. We are just taking the vertical component right now. 14.2 minus 0 is equal to 9.81, right? I'm just ignoring the negative signs here right now. So time is 1.45 seconds, right? So just plug this value in here. So this becomes 8.2 multiplied by 1.45 is equal to x. So x becomes X becomes 11.9 meters. Now, the path of the ball in A with an initial horizontal speed of 8.2 meter per second is shown again in figure 2.2. Sketch a new path of the ball for the ball having an initial horizontal speed greater than 8.2 with negligible resistance. So if this component is greater, the path would be something like this, right? You can make the triangle as well if you want, right? You can make the triangle as well on how this affects the overall resultant velocity. But I'm just going to do this qualitatively right now. Equal to 8.2 meter per second, but with air resistance. Now the velocity of horizontal component decreases. So it would be something like this, right? So the last part now. A girl stands at the top of the cliff and throws a ball vertically upwards with a speed of 12 meter per second. At the time that the girl throws this ball, her hand is at height h above the horizontal ground, right? So the hand is h. At the base of the cliff, the variation with time is given by this. So now, speed in the upward direction are shown as being positive. Speeds in the downward direction is negative. State the feature that shows that the acceleration is constant. Now, what shows that the acceleration is constant? Gradient is constant, because gradient is acceleration. Constant at, you can even write negative 9.81 meter per second square, or g. Use figure 3.2 to determine the time at which the ball reaches maximum height. So obviously at maximum height, the velocity of ball is 0, so 1.2. It's the ground at the base of the cliff. So you can see that the velocity is changing here, maximum height, and then it goes downward, downward, downward until it stops. So this is the time it hits the cliff. So this is 4.4, right? Yeah. Now on to the final part of this. So determine the maximum height above the base of the cliff to which the ball rises. So basically, this height is what we need to find here. So what we can do to find this height is just find this area here of this triangle, which will give us this height, right? Because the 0 here is this 0, and the final velocity is this velocity. So this is the area that we can find to get the answer. So 1/2 times 4.4 minus 1.2, right? This is the base, and the height is 32. So this becomes 51. Yeah, 51.2. So that is our answer here, 51.2. So this is the complete P2 practice of kinematics now. I do recommend that you go ahead and solve some questions for yourself as well, so that you'll get a good grasp on the topic. And finally, subscribe to the channel if you enjoyed the video and it helped you out.